So I just wanted to do a quick video just to talk about the greenhouse effect. This looks like a very complicated diagram, okay, but let's look at the energy balance of what's coming in. So the sun is hitting us with 5 million exajoules a year. That is, and again, the global consumption of energy is 425 roughly. So think about how much more energy the sun gives us than we could even possibly use in all of our whole world, society, and everything. So the sun is just incredibly powerful. Really, there's just, the sun is everything in terms of our energy balance. So what happens? Well, clouds reflect 25% of that light from the sun. So even if there was a small change in the amount of cloud cover, that would have an enormous amount of change in our global temperature. Okay, so let's talk about the climate models. The one concession that they make in all of the reports is that we have a really difficult time modeling cloud formation. So right there, the models have a huge gap in them in terms of their ability to predict future cloud formation. Now we know in general terms, if the temperature goes up, more water will evaporate, more clouds will form, okay? And then we will have, the tipping point is not actually a runaway heat, it's an ice age. But the cloud formation moderates our temperature. So that's one of the things. So the warmer it gets, the clouds form and it cools us back down. And so that's one of the balances, is cloud formation. Also one very difficult to model, okay? So 23% is absorbed by the atmosphere. That's typically the UV light that comes in and some of the infrared, okay? And then 46% hits the surface. Now, some of that's reflected by the surface. And so if we have a change in snow cover, then more of that will be reflected by the surface. So it comes in visible, goes out visible, okay? We have concrete versus asphalt. This is its percentage of reflectivity of the surface is called albedo. And so the higher reflective the surface, the more albedo, the more it reflects out. And then if you take away certain structures that are reflective and you pave them or put asphalt down and you make them non-reflective, then you change the albedo, but not a lot. I mean, if you look from Google Maps, you don't see a ton of asphalt. Okay, so it's not like you say, oh, an asphalt parking lot. But again, asphalt versus concrete, that has a small difference in the local area. And so that's why we do have an urban heat effect. So as we put more structures down that absorb, then the urban areas get warmer relative to the rural areas. I even noticed this riding my motorcycle, because when you're riding your motorcycle, your body is in intimate contact with the wind, the air around you. And so I would drive out of Huntsville and go into my neighborhood. And as soon as I got under the canopy of the trees, 4 or 5 degree difference. I would just feel the temperature drop. Anyway, and that's the tree canopy helping. Okay, so that's the reflected by the surface, but the amount that's absorbed by the surface then needs to emit. And so this is the greenhouse effect right here. So when we talk about greenhouse gases, it's this one right here, that 37% absorbed by the atmosphere. That keeps us from freezing at night, right? If you think about it. So if the Earth turns and the sun's on the other side and it's dark, it's going to get really cold unless we have an atmosphere. But because we have an atmosphere, that atmosphere keeps us warm. Now that you know this, I want you to pay attention. The next time you're outdoors on an evening, say spring or fall, is when really you notice it the most, if it's a cloudless night or a cloudy night. The cloudy nights by far are warmer than a cloudless night, because that water is absorbing a lot of that infrared heat and it's just making a comfy blanket. You go out in the spring, it was say a nice 65 in the daytime. If there's no clouds, it'll drop into the 50s and 40s at night, like almost immediately if there's no clouds. If there's clouds, it'll only drop 5 or 6 degrees, maybe 10. And you can definitely tell the difference. So it's one of those things that once you notice it, then you notice it a lot. And so now that I've put that in your mind, pay attention when you go out in the evenings, whether it's cloudless or cloudy, and you'll definitely tell a difference between the temperature. Okay, this amount a lot of this has to go through the clouds. This 9% here that gets through the atmosphere and through the clouds, that's key. So it's this balance between these two. If you think about changing that balance by an enormous amount, an enormous amount may be 1%. So instead of 37% absorbed by the atmosphere, 38% is absorbed and only 9% is emitted. That's going to change our nighttime temperatures. And we're not going to get all the way back down to where we would have gotten without that gas. And so then the sun comes out the next day and heats us up a little bit more. So if we have that greenhouse gas that's absorbing just 1% more, then it's going to have an effect on our ability to cool at night. We want to cool some to get rid of the heat from the previous day and let the sun warm us up again the next day to keep our temperature stable. But if we have too many greenhouse gases, they form a canopy that keeps the heat of the sun in. So again, 1% of the sun's radiation, it's 500,000 exajoules. Just 1% change. It's huge, 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 huge. Now, water, a lot of people, they focus on CO2, and I even saw it in some of the documents, the IPCC, the Intergovernmental Panel on Climate Change. They said, well, we have to focus on CO2 because that's what we can regulate. We can't regulate water. So right there, I was like, oh, so this is about regulation. But water, is by far the most important greenhouse gas. That is the thing that really moderates our temperature. And in terms of our worst case of fossil fuels, if we used all coal, which is 5 times the worst possible case, we would change CO2 by 1%, maybe. And so then nature is, this CO2 balance is really a function of nature. We're along for the ride. So anyway, that's the greenhouse gas. This balance between the greenhouse effect, that balance between what gets through the atmosphere and what's absorbed by the atmosphere. Okay, so that's the energy balance. This spectrum here, this is an old spectrum, but still it shows you the windows. So wavelengths and microns. This is all in the infrared. Okay, and down here's the visible, this open area. These little green dots here, those are the open windows for that infrared light to get through. And so it's not so much that we have CO2 shows up right here. So this is CO2. But like this little gap right here, CO2 has no effect on that gap, but other gases might. And so we really would worry about any kind of gas closing that window. And here, CO2 doesn't affect this window at all either, or this window. So those windows are wide open. But if we start putting in, tons and tons of chemicals that close those windows, then we really will have a problem. Okay. But again, how much would we have to put out there to actually change the absorption profile of the atmosphere? The atmosphere is absolutely massive. But we still want to pay attention. So that's where the greenhouse gas regulations come in with solvents. Now, it affects me in my cleaning because people don't want to have solvents being blasted out into the atmosphere. But even then, it's just impossible to conceive how we could put enough in the atmosphere to affect it. But if it's catalytic, like the ozone depletion, you might have an outsized effect. So it's good to pay attention to, but it's by far not something we need to panic about. So I know that there's a whole condition about climate anxiety. You guys do not need to have climate anxiety. Okay. All these politicians that are beating the drum over this, guess where they're buying their mansions? On the coast. You think they're worried? No. If they were worried about ocean level rise in the next 20, 30 years, they would not be buying beachfront property. Okay. I don't need to name names. You can find that on your own. Okay. All right, so that's enough for that. But I just wanted to kind of get you guys to relax a little bit. I know that your generation is being terrorized right now. Unnecessary.